Hello class and welcome back. In this unit in exponential functions, we're going to talk about, you guessed it, exponential functions. So to start off, I just wanted to give you a little introduction. This may be review for some of you, but it's always good to remind ourselves of what we're talking about here. So this is your classic exponential function, what you have of here. F of x is equal to b raised to the power of x. So let me break this down for you a little bit, then we'll do an example. This b here is a real number. It's a constant value. So in this equation, b is a real number. B is positive. And b is not equal to 1. And you call this number b is called the base. When we move into talking about exponential growth and exponential decay, you'll see that the base is going to have a lot to do with whether we have exponential growth or exponential decay. And that's called the base. And then we have our variable up here in the exponent. X is our variable, our input for our function. And x is our variable. And it can be, x can be any real number that you like. So let me give us a little example here to work with. Let's take a look at an exponential function. Let's say we have the exponential f of x is equal to 5 times 3 to the x plus 1. So one thing to note here is it's really important to know what's your base and what's your exponent, because your exponent only applies to your base of your exponential function. In this case, your base is 3. And you know that your base is only 3 because of these parentheses here. That's what they're telling you. They're telling you these things in parentheses, that's what this exponent is referring to. So this exponent here, this x plus 1, is only applied to the base. And I think it'll help us if we actually find a value here. So let's go ahead and find f of 2. So just like with the other functions we've worked with, when we find f of a value, what we're going to do is see that everywhere where we had an x in our previous equation, we're going to plug in 2. So f of 2 is going to be equal to 5 times 3 raised to the 2 plus 1 power. And now what we have to do is follow our order of operations, and we'll be able to evaluate this thing. So this will become 5 times 3 to the third. That's just me adding together 2 plus 1 to get 3. And then now I'm taking 3 and I'm raising it to the third power, and that gives me 27. And then when I multiply 27 by 5, I get 135. Don't be too impressed at how fast I'm going. I did this with a calculator before I even started the video. I'm not doing that off the top of my head. I wish. Okay? This is an exponential function. There's a common mistake students make where they say, here's our big mistake. Here's a mistake that we make a lot. And I see why it happens. I wonder if you guys will have sympathy for this mistake. Students say x squared is exponential. And I'll say, why? Why is it exponential? And they go, look, Sarah, here's an exponent exponential. That's not an exponential function. X squared, we've worked with this before. X squared is not exponential. For a function to be exponential, you actually want the exponent to have the variable contained in it. So let's give an example of something that is exponential. 2 to the x power would be exponential because the exponent has the variable contained in it. And so this is just a little bit about how to recognize and work with exponential functions. And in the next video, I'm going to do an example for you about exponential growth of a population, which is a very common problem. And then I'm going to give you guys some stuff to look about, to learn about how COVID behaves in an exponential way. It's very applicable to our current lives, sadly. But while you're learning, I hope you're staying safe, and I will see you in the next video, my friends.